If the scatter plot you're looking at has a linear form to it, then we say there is linear correlation, or simply we just say correlation. Now, correlation can be either positive or negative. A positive correlation is a relationship between two variables where, as one variable increases, the other will also tend to increase as well. Both in this case, like x or y, as one variable increases, the other will also increase. As one decreases, the other decreases. So the more time you spend running on a treadmill, for instance, the more calories you will tend to burn. Taller people tend to have larger shoe sizes. Maybe not in every case, but just as a tendency, that'd be a positive correlation. A negative correlation means that there is an inverse relationship. That is, as one variable increases, the other will tend to decrease. So a student has many absences will tend to have lower grades. And as temperatures get colder, heating costs tend to increase. If you suspect a correlation exists between two variables, so if you look at a scatter plot and it looks like a line can go through your points, it can be measured with what's called the correlation coefficient. The correlation coefficient, which we use the letter R, either lowercase or uppercase, is a measure of the form, strength, and direction of a scatter plot, and all in one number. And that number is always between -1 and +1. So here are 8 graphs. So what can we see about the correlation coefficient? Well, you notice the graphs on the left are both around 0 and 0.33, -0.08. These are the two graphs that are around 0. And you see that there really isn't any real pattern. These both look fairly vague, like a vague swarm of dots. In the top row, as the correlation coefficient increases, you see that the graph looks more and more like a straight line. Like a line can go through every single point. And finally, we get to correlation of 1.00. It does appear does indeed appear that a line can go through every point. The second row deals with negative correlations as it gets closer and closer to -1. And as I get closer and closer to -1, it looks more and more like a straight line can go through the points. The only difference is the points are going downwards. So, one way to interpret the correlation coefficient is in terms of focus. Values close to -1 or +1 will have very clear pictures, whereas values close to 0 will often look like a vague swarm of dots. You can see in terms of the different graphs here. -1 is very focused, very much like a line going downwards. 0, it's all over the place, has no idea what's happening with that. And then it starts increasing again, you get to +1. Again, very focused. Now I say often looks like a vague swarm of dots because 0 could mean other things. So correlation coefficient close to 0 can mean other things such as a nonlinear pattern. In fact, all the graphs you see on the screen here, all these have a correlation of 0. So it really can't be emphasized enough that the scatter plot must be analyzed first before making any conclusions about correlation. That is, don't rely on just a correlation coefficient. All right. So let's go ahead and match the correlations with these 4 scatter plots. And for these, I would like, when I look at these, I tend to take the ones that are closest to 1 or -1. Because those are the ones that are going to be closest to looking like a line. So for instance, D here, -0.85, that's the closest to -1. That should be on the graph that's clearly going downwards, in a line. And that appears to be graph 1. Now, let's see here. A and B deal with +0.49 and -0.48. So those two graphs should look similar, except one is going upwards and the other is going downwards. So you see those match up with graphs 2 and 4. And the remaining one, part C, a correlation coefficient of negative 0.03, that's going to be the one that looks like a vague swarm of dots, or it's going to be the one with the nonlinear pattern. In this case, the nonlinear pattern.